Let's take a look at some sample problems from section 7.5. I'm working from a few exercises in the textbook, starting with number 10 on page 337. We have negative 5 to the fourth. Okay, notice when we raise a negative number to an even power, we're going to end up with a positive. And I'm going to expand this one just to show you why that occurs. If we raise it to an odd power, we would get a negative number. But in this case, negative times a negative gives us a positive, times a negative gives us a negative, times another negative gives us a positive. So we're going to get positive, let's see, that's positive 25, negative 125, positive 625 for that one when we expand it. Let's take a look at our next one is number 16. I have 4 to the negative 1. And our directions are to evaluate each exponential expression. And when they say evaluate, that means we want to write it without any negative exponents. So the negative exponent means take the reciprocal, so we just get 1/4. 22, we have 1/2 to the negative 3. Okay, again, the negative exponent means take the reciprocal and raise it to the positive power, so we have 2 to the 3, which would be 8. In 28, we have 8 to the 0. By definition, any number other than 0 to the 0 power is equal to 1. Number 34, we have negative 8 to the opposite of 8 to the 0 minus 7 to the 0. Now notice the difference between this one and this one up here. In number 10, we have parentheses around the negative. Here we don't. So what's happening is we're raising only the 8 to the 0, and then we're taking the opposite, or thinking about multiplying it by a negative 1. So that's going to be a negative 1. Minus 7 to the 0 is also going to give us a 1. So negative 1 minus 1 would be a negative 2. So be careful with that. You have to watch out for those parentheses. In number 40, we have x to the 12th divided by x to the 4th. And remember, when we're dividing, we subtract the exponents. We have the same base. So we get x to the 8th. Number 46, we have 12 divided by 12 to the negative 1. Well, that one needs to move up on top. We get 12 times 12, which is 144 because of the negative exponent. 52, we have k to the negative 5, sorry about that, negative 5. Got to read more carefully. K to the negative 3 times k to the 4th. Okay, so we want to add our exponents. Negative 5 plus negative 3 would be negative 8, plus 4 is negative 4, which is 1 over k to the 4th. 58 is 3a squared times negative 5a to the negative 6 times negative 2a. Okay, so we want to multiply the numbers, the constant part in front. 3 times negative 5 is negative 15, times negative 2 would be a positive 30. Multiplying the a's, we'll get, we can add the exponents, we get a negative 4. Remember, this implies a 1, so negative 4 plus 1 would be negative 3, and that's 1 over a cubed. We can think of that as 30 over 1, so we get 30 over a cubed. Okay, moving on to number 64, we have m to the 5th raised to the negative 2 times 3m to the negative 2 cubed. All right, now in this case we have exponents outside the parentheses, so we need to simplify those exponents outside. So m to the 5th raised to the negative 2 would be m to the negative 10. We want to multiply our exponents. All right, now we have to cube 3. 3 cubed is 27. M to the negative 2 cubed, we multiply the exponents, we get m to the negative 6. So in front we have a 27. Adding our powers of m, adding our exponents, we get negative 16. So that's going to be 27 over m to the 16th, because this is 1 over m to the 16th. And we would think of this as 27 over 1. Okay, number 70. We're to write the given number in scientific notation. We have 46,500. Okay, so we look at the non-zero part. Look at the non-zero part. We place a decimal so that we have a number between 1 and 10. Now we have to figure out how many places and in which direction. We need to move it 1, 2, 3, 4 to the right, so that would be a positive 4. Okay, 76, we have 1.63 times 10 to the negative 4. This time they want us to write it in decimal notation. So we start with our 163, 1 place, 2 places, 3 places, 4 places, so that's where our decimal would go. So we get 0.000163. And one last one, when we're doing computations, let's see, we have 0.018 times 20,000 divided by 300 times 0.0004. Okay. All right, what we can do in this case is we can change them all to scientific notation. Okay, so 1.8, we need to move it 2 places to the left, so that would be a negative 2. And then 2.0 times 10 to the 4, positive 4. And then 3 times 10 squared for the 300. And then 4, put the decimal in there, times 10 to the 4, negative 4. Okay, looks like I'm going to have to move up here to finish this one. Okay, so 1.8 times 2 is 3.6. We multiply these numbers. Then we multiply our powers of 10. That's going to give us 10 to the positive 2. Divided by 3 times 4 is 12. Times 10 to the negative 2. If we multiply these together. Okay, 3.6 divided by 12. Clear. 3.6 divided by 12 is 0.3 times, and our we're going to take 2 minus a negative 2 would be 10 to the 4th. So that's going to give us 3. Have to move it 4 places over, so 1, 2, 3, 4. Looks like 3,000. Oh, they want it in scientific notation. That would be 3 times 10 to the 3rd. After all of that. You could also find the answer, just compute it decimally on your calculator. Just make sure that you put parens around it if you do it that way. And then convert it to the scientific notation like I did at the end.